Okay, this is the last lesson of the electron chapter or section that we are dealing with. At this point, what we're going to do is we're going to actually come up with something that is extremely useful for the next chapter, which deals with ionic compounds, which will begin the next week. The title NGC, OEC, and VE describes the three areas that are fairly easy to follow along the logic for. And like I said, the VE in particular is the one that we're going to be using next week. NGC stands for noble gas configuration. Now, what that means is this. So let's suppose we have gallium. Again, you're going to need your periodic charts for this. And we're going to put down the electron configuration for gallium. We call the electron configuration now C. And gallium's number 31 right here. So we go 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, and that leaves us the next element after zinc, which is gallium, which will then be a fourth level p electron in the first one. Okay? Now, at this point of your short career in chemistry, you probably get pretty sick and tired of writing all these 1s2s, 2s2s, and so on. To the point where you actually probably remember the first half pretty well at this point. Wouldn't it be nice if we didn't have to do that? Well, there is a shorthand form or abbreviation form for this, but we're going to use this point that will help us do the next two parts. I'm still going to expect you to know electron configurations, and you will be needing to use that from here on in. But the shortened form helps as well, and that's the noble gas configuration, NGC. And the noble gas configuration, if we take a look at the chart here, we look at the noble gases that we go past. We go past helium, we go past neon, we go past argon, and we don't quite reach krypton. So the last noble gas we went by was argon. Now argon is 1s2, 2s2, 2p6, 3s2, 3p6. All of this right here represents argon. So what we're going to do in this abbreviated form is we're going to put AR in brackets. And then everything else after that gets written out. 4s2, 3d10, 4p1. And that is the noble gas configuration for gallium. Everybody is assumed to know that this noble gas, all noble gases end in P6. But there's a bunch of different stuff in the middle between the 1s2 and the 3p6, which you can all scrunch into this AR. So let's do the same thing with protactinium, PA. Protactinium is all the way down in, it is the second 5F here. So I'm going to write this out real quick, like 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, 4d10, 5p6, 6s2, 4f14, 5d10, 6p6. And that takes us up to radon. And the next two are 7s2. Then we have actinium next. That is a D. That's one related to that 6d1. And then we got two of the 5Fs for thorium and protactinium, so 5F2. That is the entire electron configuration for protactinium. Now, if I wanted to shorten that, using the last noble gas, like I said, that goes all the way up to 6p6. So this whole thing from here to here can be scrunched into Rn. And then everything else after it, 7s2, 6d1, 5f2 follows. Okay? Pretty nice, isn't it? All right. So, now the next thing we're going to talk about is the OEC. Now OEC stands for outer electron configuration. Now what that simply means is that we take the outermost level, the highest number n value for the quantum number, all the electrons in that gets put into what we call the outer electron configuration. So let's take a look at gallium. So we go back, let's go to the MGC for that, because we don't need all that other stuff. So right here, 4s2, 3d10, 4p1. Well, what's the highest level then? If you know your numbers, it's 4. So we ignore the 3d10 and we look at 4s2, 4p1 as the electron configuration in the outermost level. Okay? So that becomes 4s2, 4p1. And for protactinium, it gets even easier because as you can see here, 7 is the highest number, and that's the only 7-level electron we have, so it's just 7s2. Now this one is, people make mistakes on, go, oh, we got a 4 here, 4p1, that's the highest one, I'll ignore all the others. No, you have to include all the electrons in the highest level, the s's and the p's both. You'll notice when you do this, that are all going to be either just s's or s's and p's. There will never be d's or f's involved in your outer electron configuration. They always go underneath the highest level at the point at which they were coming in. The last bit of information is the number of valence electrons, which we call VE. VE stands for valence electrons. And we're going to be looking for how many of those valence electrons. This is big. This is the one that determines how atoms react with each other. Now the word valence means outermost level. So the question is, how many valence electrons do we have here? Well, this one right here, you got 2 here and 1 here. So the number of valence electrons, excuse me, is 3. And here we just have 2. So the number of valence electrons is 2. And like I said, that is useful information for the next section that we're going to get into, which deals with ions and ionic compounds. So, there you have it. Let's take a look at the practice problems. You're going to give the noble gas configuration, the outer electron configuration, the number of valence electrons in these 5 elements. Have fun!